Hello, everybody, and welcome to yet another Zoom conversation. Another geologist, one of my favorites, Hannah Shamloo, Dr. Hannah Shamloo at Central Washington University. Hannah, what is the weather today in Ellensburg, Washington?
Hello, Nick. Thank you for having me. So the weather is actually really nice. It's gray, but it's warm. We got beautiful snowfall this morning. Very nice walk into work today. So I
Thank
can't
you.
complain much.
You cannot complain. We cannot complain. We are both in the same building, looking out the same windows. Hannah's one floor up above me, and we begin talking about the Goat Rocks Volcanic Complex project funded by the National Science Foundation. Hannah, did you write the proposal primarily? Was it a team effort with you and Kelly? And what was the original plan with what you would do in the field and in the lab here at
Mm.
Central with your project?
Yeah, so the birth of this proposal happened, and Kelly kind of alluded to this. It happened in New Zealand, actually. So I had
Yeah.
known Kelly. I did a postdoc at Oregon State while she was still a student there. She gave a talk in just a research meeting, and I was blown away by her immediately. I was like, wow, Goat Rocks is cool and Kelly Wall is cool. And so we became friends. But then in New Zealand at this meeting called IOFC, we were both there and literally having lunch on the curbside outside of the building one day. And I was like, your Goat Rock stuff is super fascinating. And I was asking her a bunch of questions. And then I'm like, would you be open to writing a grant with me? And so it was from that simple conversation that this whole 4-year grant was born. So I think I took a large lead on writing it, but she was a huge help because the Goat Rocks she knows it inside and out, right? Her whole PhD dissertation was on the Goat Rocks. So I couldn't have done it without her. So it was definitely a team effort.
You're the one with the students, however. So she's a co-PI, but you're the one that's got the whole architecture. You've got the lab, you've got the plan. You're the one that lives closest to the
Yeah,
field area.
yeah.
So who are the personnel involved? Just quickly, maybe names wise, and I think you've got a couple photos you can share in a bit. But how many students and what kinds of students are involved with you so far?
Yeah, so it's a 4-year grant. And so the goal is to support multiple generations of master students and undergraduates. Currently, the Goat Rocks student team is one of my master students, Haley Finch, who you guys have met now on YouTube
Yeah.
with Zircon work. And then I have an undergraduate working with me, James Gennaro. And then I had Yusei O'Leary, who has now graduated. And then I have two new undergraduates, Jess Maynard and Julie Wake, who are going to be working on some of those Devil's Horns Rhyolite mafic cobbles that you guys have been talking about on this channel. So got a really nice team assembled, and this is just the beginning. We are still in year one. So yeah.
I'm grinning in part because those kids are in 101 with me on the first floor, and before I know it, I blink my eyes and they're up on the second floor.
It's
You don't you
cool.
don't you don't extend your hand to everybody, so those students earned it, and you're picking now who you want to deal with, both undergrads in-house, and then I mean the competition to work with you will continue to increase as the word gets out about this incredible project you've got going. Let's talk about the specifics of the project. When you wrote the proposal, were there a few main objectives, and where are you with those objectives to date?
Yeah, so the proposal is three-prong, two kind of large objectives, a third kind of wrap-up objective. So the first objective is just characterizing the magma mush storage system beneath all these vents at the Goat Rocks Volcanic
Mhm.
Complex. So the 4 phases that you and Kelly talked about in her
Yeah.
interview, but also before those 4 phases. So the earliest record of Goat Rocks, so those early mafic and felsic units that precede these 4 strata cones that are producing andesites. So like basic petrology hasn't been done on these units. Kelly did a
Hmm.
phenomenal job in her dissertation work dating the units, mapping the units. Thank you, Kelly. What she didn't have time for, otherwise she'd be doing her PhD for years and years and years,
Right.
was just the fundamental petrology. So looking at different magma components in these storage systems, the temperature, the residence time. So how long are magma stored at the Goat Rock? So kind of these fundamental petrologic questions that I'm curious about. So that's prong one.
Yeah.
Is like, let's just get in, let's start visualizing a framework to start thinking about the magmas beneath
Good.
these different vents. So that's prong one. Prong two is because we have the rare exposure of a full life cycle of a volcanic complex in the Cascades. That's why Goat Rocks is so captivating to me. because you have the earliest and the latest record all on display. Thank you,
Mhm.
glaciers, glaciation. The second prong is basically asking the question of how do you birth a volcanic complex in the
Yeah.
Cascades? And the way we're attempting to answer that question is trying to understand what is the influence of the basement rock. So you've spent all your rainbow A to Z basically discussing basement in this area. So how do those different layers influence the magma and basically influence the eruptibility of those magmas to through time? So in the earliest part of Goat Rocks and the latest part. Right now we're focusing on the earliest part because we have this rare opportunity to study the birth of a volcanic complex in the Cascades. So that's very exciting to me. So that's actually what Haley Finch is working on.
Okay.
And she
Well,
won't be the only person too. Yeah.
yes. So it's those earliest days where you're blazing the biggest trail, it seems. Like Kelly was working on those 4 cones. Would you have been interested in the Goat Rocks project if there wasn't that silicic volcanism that is kind of your wheelhouse?
Yeah, that's a great question. I think it still would have been interesting, but you're definitely onto something where my training and my PhD was on Yellowstone. So not thinking about the mafics there, just thinking about those rhyolites, specifically these caldera forming super eruptions. So like I
Yeah.
came from a very extreme end member of volcanism at Yellowstone. And so that's kind of where I was trained. But yeah, so the caldera forming Devil's Horns rhyolite definitely, especially when Daryl, John, and Kelly took me to that outcrop, which you and I have done a video there.
Yeah.
That was definitely like, okay, I'm sold. This is so cool. I need to know more about this.
So I have to confess something. As I've gotten into this alphabet and started to work my way through those bedrock units and potential influences to that earliest days of the Goat Rock scene, I think I've lost track of what you're trying to find. Are you working? You were sampling all the bedrock units that potentially influence 3.2 million year old Kaboom at Goat Rocks.
Hmm.
But then are you going to take all that geochemistry detail from all those samples you collected last summer and compare them with something you're finding in the tephra from the explosion like this
Yeah.
summer or next summer?
Yeah, exactly. And I think if you're feeling lost, it's because we're asking so many questions
Yeah,
and
yeah,
we only have time to answer one at a time, right? Our master student is only with us for 2 years. In reality, it's
yes.
1.5. So yes, if you're feeling confused, it's because we're just blasting questions left and right. So what Finch specifically is doing is looking at the Merriam Creek dacite and the Devil's Horns rhyolite. So these are two silicic eruptions in the earliest days of the Goat Rocks Volcanic Complex.
Mhm.
And exactly what you said, we have also sampled basement in that area. So that includes Rimrock Lake, some Eocene age things, and then Ohanapakash. And then even some basement that is exposed, like older volcanics that we don't know where the source vent is. So she's characterizing the geochemistry of the basement and then characterizing the geochemistry of the early silicic Goat Rocks volcanics and going to compare them. So you and Jeff Tepper talked a lot about spider diagrams. So that's something in our toolbox as well. So like looking at the bulk geochemistry as well as Zircon geochemistry
Mm.
in basement versus Goat Rocks volcanics and seeing if there's an influence or any kind of overlap there. So we're trying to get at how much is the basement influencing Goat Rocks magma and eruptions.
So that hints at the idea, maybe it's more than a hint. The first signs of life in that Goat Rock scene is the supervolcano explosion in this non-volcanic basement scene. I was just talking to Dave Tucker last night. Did you
Yeah.
happen to see that interview?
Yes. So cool.
Is he kind of implying that as well? Like, I don't want you to speak for Dave Tucker, but like he's got the Hannigan and the Colshan, especially the
Right.
Colshan. It seems like every block inside of that mapped caldera is not volcanic. It's
Right.
this old basement. I wonder if your caldera, as you get to know it better and better and get to know that interior caldera fill, is it also just going to be a bunch of very old
Yeah.
bedrock, maybe mostly Russell Ranch? I don't know.
Yeah, that's exactly our question. I think you're articulating that really well. And Dave Tucker's interview was actually really exciting to me because first of all, there's way more calderas in the Cascades than I realized. Like,
Same here.
I'm just gonna say it, okay?
Same here.
I'm a caldera lady, but that's Yellowstone. But thinking in Cascades, I was like, okay, yeah, I'm definitely ignorant on the amount of calderas that we have mapped and that we know about. So I had the same question watching Dave's interview, which was, do these caldera forming eruptions mark the onset of these volcanic systems? Like, is that, and that's one of the questions we're asking with this proposal too. I don't think we're going to be able to answer it in just one project, but
No,
is there some sort of time pattern? Yeah, I think if I'm not going on a tangent here, is there?
you're not. No, this
Yeah,
is like, come on, man. If how weird is the Goat Rocks area?
right,
To start
right,
with a bang and to
right,
have that caldera blast a hole in a place that hasn't been active cascade wise
right.
for tens of millions of years earlier, is that the birth? Is there a
Yeah.
caldera at the birth of Rainier? Is there a
And
caldera at the
Baker,
birth?
yes, I have the same question. And yeah, that's one of our questions here too. I don't know how we're going to answer it immediately. I mean, Finch needs to do some characterization of geochemistry and some ages, but I think in future generations of CWU students here, I feel like that's something I want to work towards is how unusual is it to have this caldera forming eruption? How do you get a caldera forming eruption in the beginning of these volcanic complexes in the Cascades? And again, it comes back to how is the basement influencing the magma in the earliest parts of volcano's life?
And it sure seems like a Pluton is almost always younger than the caldera. It's
Yeah,
coming
that
up
was
through the
cool.
caldera.
Yeah.
Like I'm getting confused there as well. Is there a known Pluton that's slightly younger, or what is there a known Pluton in the Goat Rocks area? And is anything known about its age or its relationship with that caldera?
I had the same question, Nick. And so when I was watching Kelly's interview, it seemed like there's some shallow intrusions exposed, but that's not like I want more. I'm
Yeah.
unsatisfied. I mean, maybe that's all we know, but I'm
Huh.
also unsatisfied with where is the Plutons? Because something, I mean, you were talking about with Isla, this is something that just the field in general is interested in is this plutonic volcanic connection.
Yeah.
And to have both a Pluton and a tuff exposed in an area is really cool.
Mm,
So
mm.
yeah. So I'm
Okay.
not giving you answers, but I am asking questions with you.
You just started the project, and yes,
Just started.
you have experience at Mount Baker, and I assume you're taking some of those techniques up at Baker and
Yeah,
working with your first prong down at Goat Rocks. You're going to
exactly.
have okay, all right.
Yeah,
So
exactly.
makes sense to me. Uh, would you mind sharing your screen? I know you have a few visuals for us. I don't know what
Yeah.
they are, but it'd be fun to add some visuals. But we've already gotten to know you a little bit through the magic of YouTube videos thus far. Oh, here we go. I recognize some of those
You know
folks.
these people. Yeah, so
Yes.
I wanted to include just some photos of the team we've assembled here, just because
Thank you.
we have a really great team. So summer, you joined us for some of this. We did our first field campaign on this grant. And
Yes.
so the team we had assembled, I want to first start by thanking Daryl Gussie and John Lasher. So they both have made appearances on your channel.
Mhm.
They were so instrumental in showing us this area and basically shepherding us around. And they have such an extensive knowledge. So very appreciative of them. Kelly Wall, of course, over here. Fuji the dog, who is actually the PI of the grant. No. And then I have two new graduate students. So this is Sabrina Ansari here, Haley Finch, who you guys have met in a previous video working on
Yes.
Zircon. And then I have
Yes.
two undergraduates here. So I have James Gennaro, the fourth here, and then Yusei O'Leary, who has now graduated and moved on. But yeah, this was our little Chives. Chives is the name of my lab group. Chives Goat Rocks team. So
Good.
this is Goat Rockers from last summer. And in this field campaign, we managed to collect quite a bit of loot. So we have almost 50 samples here. We
Nice.
didn't do any kind of backcountry expeditions. We stuck to kind of forest roads and along Highway 12 here, which is shown in red. This is
Yeah.
remarkable. But yeah, we did cover some good ground. I think for a first field campaign, getting our feet wet with this area, I think we did pretty good. And so our main objectives here, again, we're getting those silicic units for Finch to look at. So the Miriam Creek Dacite and the Devil's Horns Rhyolite, but then also basement rocks. And so that what you're looking at, these sample sites in this area is basically an array of those types of rocks.
So how, I know you got some help from John and others, but how did you specifically target these places? Was it Kelly saying you need to go there, you need to go there, you need to go there, or how this almost? I know this is following mainly roads, but is there more
Yeah.
strategy involved in that?
Yeah, that's a great question. So I wouldn't have been able to do it without Kelly, Daryl,
Hmm.
and John. They know, again, they know the area so well, but also my
Right.
own research of just like you've been doing on this channel, just scouring through old literature,
Yes.
like Clayton and Swanson, like anything I could get my hands on, just trying to figure out where are these basements exposed in an easily accessible way. So my own research as well as checking in with my colleagues is how we made this
Great.
happen for sure.
Great.
Yeah.
So all those sample bags are upstairs someplace as
Yep.
we talk right now.
Yep.
And have they all been dealt with so far by those students, or is there some waiting
Yeah.
for another student to show up?
So big shout out to my undergraduates here. So James and Yusei went
Hmm.
through every single sample.
Mm,
They cut a piece off for whole rock geochemistry, so a hand sample, and then
yeah.
they prepared billets for thin sections for like literally 50 rocks. So
Wow.
very grateful to both of them. Those have now been sent off to Washington State to get geochemistry done and off to Wagner Petrographics to make thin sections. They are entirely responsible for that. And then Finch, of course, you guys saw in the lab in a previous
Hmm.
video working through Zircon. So she's worked on, I mean, she has 11 samples to process to get Zircon, but she's worked on more than that. So she's
Sure.
crushed some of these and gone through the processes. So yeah. And then Sabrina here is actually working on Mount Baker. So she's
Hmm.
not working on Goat Rocks.
Okay. Good. Thank you. You got anything else to share?
Yeah, so I
Oh,
thought it'd just be nice to highlight some of the student projects that are already in motion at Goat Rocks. So
good.
the first time that Chives Goat Rockers made their debut was actually at GSA Spokane. So this is a regional meeting in Washington. This is Yusei and James presenting a really nicely put together poster. So they were looking at two mafic units in the Goat Rocks. One of Hogback Shield volcano that's like midlife Goat
Hmm.
Rocks, and then Devil's Wash Basin, which is early Goat Rocks. And they were basically trying to figure out how long does it take between what's the time that passes between a magma in storage and a magma erupting. So that
Yes.
final ascent path, and their work showed around few years, no more than a few decades. So really short amount of time that it takes to kind of turn a volcano on in this
Mm,
area, if that
mm,
makes sense.
it does.
So that's James and Yusei.
Okay.
Some ongoing work. James this quarter with me is going to do some thermometry on some of these mafics at the Hogback Shield volcano. Again, these basic magmatic conditions we don't know. So like how hot was the magma stored prior to eruption? So James is going to apply some mineral thermometry on this deposit. This is James standing on the Devil's Horns rhyolite. You have been talking about the mafic cobbles in this unit. I have
Yeah.
Jess Maynard and Julie Wake are going to be working on the geochemistry and the petrology of these mafic cobbles to figure out where they come from.
Mm,
So they're on it. This is also a picture of them working in my magma lab upstairs. So
hmm.
this is undergraduate work happening. And then you guys know about, we can talk more about Finch's project in depth, but this is Miriam Creek drainage that we hiked along to get some dacite lava along this drainage.
Nice.
Yeah, that was an exhausting trek, but we did it. Everyone was
Good.
tired by the end of that.
Yeah.
Yeah.
Okay. Yeah. Please. Yeah. You got. Let's just burn through the rest. Oh, is that it?
Well, those are the student photos. I mean, I have some figures of
Oh, you know what?
basic.
Let me stop your share.
Okay, yeah, go
I
ahead.
think I can do this.
Okay.
And let's transition in the time we have left. I know you're a busy gal to Haley's project.
Mhm.
And I guess if I start mentally going to Haley's project, I think of what I was doing this winter and basically looking into the camera and like, Hannah, I don't know. I don't know if all those bedrock units are really there for when
Yeah,
you're going to do your big kaboom. Is it all
yeah.
ugly Russell Ranch or
Oh
are
man,
really? And so, how are you feeling about that? Like, did you
I
do
love
you
it.
have why did you sample all those different bedrock units? Did you have an inkling that there was more than the Russell Ranch that went into that early days of the Goat Rock scene?
Yeah, so I will, let me share.
Good. Yeah.
Share one more time just to show you this figure.
Great.
So yeah, I really liked you posing this question of like the timing of uplift versus what basement's actually there when these things are erupting. The
Hmm.
reason we did such an extensive sampling of basement is because from Kelly's dissertation, so this is a figure that has been modified from her dissertation.
Hmm.
These are all zircon ages.
Hmm.
All the Goat Rocks Volcanic Complex, I know there's a lot going on here, but all these points, these are zircon, individual zircon ages from Goat Rocks Volcanics.
Makes
But then
sense.
over here, these are all the basement units that we've been talking about in your A to Z series and also in our proposal.
Yeah.
Everything circled in red are zircon ages that were erupted out of a Goat Rocks eruption, but have the same age, not as volcanics from Goat Rocks, but their age is as old as these different basement units.
Their age. I see.
Yeah, so this is the first hint that at some degree, our
Hmm.
basement is interacting with our magma prior to eruption because we're basically inheriting zircons. And in a Goat Rocks eruption, we can inherit zircons as old as Rimrock Lake, Summit Creek, Ohanapekosh, even some of these younger basements. So this was kind of the birth of Finch's project is there's hint, this is what we call a xenocrystic zircon, so a zircon that's been inherited.
Hmm.
There's already hint that the basement is influencing these magmas. Can we quantify that a little more with chemistry? So we have some age data
Yeah.
suggesting the process. Can we confirm that with chemistry? And so that's basically what Finch is doing.
Well, based on this, we don't have any CRBs. It's 16 million years old. So that's why you were thinking about basalt of Summit Creek. Is that
Yeah.
16? Maybe it
And this
is.
is around
Okay.
16. So,
Oh, okay.
I'm not against, I really have been enjoying your CRB conversation. I'm not against CRBs being those cobbles and devil's horns rhyolite. Like, I
Thank
think
you.
it makes sense. So
Yeah.
we'll
Yeah.
know, Jess and Julie are going to tell us pretty quickly here with our chemistry that we get back. So they're going to answer
So
that.
So that's it's almost like you could have this same plot in 2 years, but you're like, well, this is what Kelly had. It was just kind of an age distribution thing. Now I've got all this geochem to, yeah, for sure. This is
Yeah.
basalt of Summit Creek, that sort of
Yes,
thing.
exactly. Yeah. So
Because
that's,
it, yeah,
go
because
ahead.
it's got a spidergram plot of whatever the breakoff belt thing and that whole deal. Okay.
Totally. Yeah. Those
Yeah.
trends you see on those geochemical plots, they will change
Yeah.
depending on the processes they're recording. So yeah, this is the reason why I'm like, let's just get a suite of basement in the area and let's just test them all.
So where's the Miriam Creek whatever on this thing?
Miriam Creek is 3.5. So it's this
Oh,
pre and early GRVC. So 3.5 and then Devil's Horns is 3.2. So they're preceding the main phases. What you're seeing in these blocks of color are those four main phases that Kelly was talking a lot about. Everything here is preceding that phase or those four phases.
but I thought that Caldera was the start of starting with the bang. There is 300,000 years earlier a local volcanic center.
So yeah, there's Matrix happening before Devil's Horns, and there's also the Merriam Creek Day site.
Oh,
But
I missed that.
Devil's
Okay.
Horns is the first caldera forming eruption that it was explosive. So it's still marking the onset of explosive volcanism in the area.
Hmm.
And the most silicic, like the Miriam Day site is more mafic than a rhyolite. So it is still unique that way.
Okay. Very good.
Yeah.
How you want to go? You got some more plots, or you just want to go
Yeah,
back
let
to?
me
Yeah.
check. Okay, yeah, I guess this is a nice schematic that Finch put together when she was writing a proposal last quarter, which is cool because I've seen you draw similar cartoons to this. So I was like, we're on the same wavelength here. So
Nice.
yeah, this is basically the hypothesis we're testing is if we are in a perfect world, we're stacking these units, based on age, will
Hmm.
we see some sort of crustal influence in our mush? And we're showing one vent here, but obviously there's multiple vents. So
Right.
this is kind of the hypothetical magma storage that she's testing
Hmm.
with geochemistry. And we don't have data to show you or a spidergram to show you, but we
It's
will.
early.
We
Yeah, you
will.
will.
Yeah.
You will. Um, Good. I'm glad we're to this level of detail, and I'm learning all sorts of new stuff right now. I thought I had it figured out, but I don't. So this is fun.
Well, neither do we, so it's okay. I mean, if you want to, I can. So that's like, I've talked to you about two prongs. The third prong is how do we compare Goat Rocks to other Cascade volcanoes? And that is something that won't happen till the end of this grant. We need to collect all our foundational information first to be able to start making meaningful comparisons to, say, Helens or Adams or Rainier. So that's the third prong.
That's the third prong. And so okay, so that's an interesting thought. So you got 4 years at the Goat Rocks. I don't want to plan your next 20 years, but I mean, like just like you learned a few techniques in Baker, and now you're down at Goat Rocks using some of those with the first of your prongs.
Mm-hmm.
Maybe you run into some new techniques or new narratives or new whatever, and then you say, well, let's pick up and move to Rainier or something else. Is that possible?
Oh, I would love it, Nick. I would love it. That is the goal. I hope I have the privilege of having a long career in the Cascades in this area, and that includes Rainier. I am totally interested in Rainier. And honestly, when Dave Tucker was talking about those calderas, I was like, man, I have so many questions that I want to answer, but one thing at a time. I can't.
One thing at a time, but yeah, when I'm telling Tucker, like if I was a young professor, I'd see all these masters.
Yeah.
Of course, I was thinking of you. Like,
That's exactly.
why?
I was thinking it too. I was like, Dave, let me in. Put me in, coach. Like, let me do some stuff in that area. There's no time, but eventually it'd be cool to start working on those.
Okay, here's the last thing I want to do, unless you want to add something as well. Late in that talk with Tucker yesterday, I'm like, where is all the airfall downwind from all these things? And he's like, well, it's really old, so you can't expect to see much. I don't know. Like, I think that's what I'm going to try to do this spring with Geology 351 is to just teach myself all these known tephras in Eastern Washington, let's say. And then are we sure they're all from the Cascades, or are we sure they're all from, the last million years?
Sure.
And would you, okay, now I'm really thinking outside the box. Would you have any interest in working with tephras that are truly downwind deposits as some sort of chasing mechanism from what geochemically or something you put your finger on up in the mountains?
Absolutely. I'd be tricky because, those deposits get reworked. And so it's hard to know if you're looking at, primitive, not in the sense of composition, but like true representation of the exploded material. But you can still learn a lot, like you're saying, from the chemistry of those deposits and the minerals in those deposits and what the minerals are recording. So yeah, I mean, with my tool set, I could think of all sorts of things we could do, but I'd be surprised if we found these deposits.
I guess so. I guess that's why it hasn't happened to this point, or maybe it has and it's sitting in some master's thesis here or there collecting dust. But my gut feeling is like telling stories and saying, this thing you drive by every time you go to Pullman, well, that thing is actually a blown up part of that thing over there. It's like, what the heck?
How did so cool?
So that would be so cool. Maybe not in your sights anytime soon, but to me, I think I'm going to try to explore some possibilities like that. And just to let you know that I just got an email from Google Earth by Glenn. If you remember him from last winter with all that Brett stuff, he's got a brand new Google Earth file with all these calderas that you can zoom around and all the papers tied to it. So maybe some of this work this winter. Yes, maybe some of this can assist you somehow with the next proposal that you decide you want to write.
Exactly. Nick, we're so lucky to live in Washington. I mean, a lot of my colleagues have advised me to write proposals for Chile and write proposals for South America. And it's like, yes, the arc down there is incredible. But look where I live. I might as well. Hello. No one's even touched this area. So yeah,
Hannah, come on.
I know. You know what I mean?
I love what you're saying there. Thank you. I love what you're saying.
Feels good to live here. Yeah.
Dr. Hannah Shamloo, thank you for your time today, and we will check in with you again sometime down the road to see how things are going. But thank you for everything. Let's talk in a couple minutes, but let me stop the recording here. Thank you, Hannah.
Thank you.
Bye-bye.